Okay, we're live. All right. All right. So this reminds me of the this being a proportion just automatically just reminds me of what we learned in the when we're doing the quantity inferences and the two independents, and
Yeah.
that's pretty much all it reminds me of. Granted, we're not composed with a lot of data to come by. So I mean, a lot of the things. So, like, what's the null hypothesis for you? So, then, like, number one, what is the null hypothesis? Um,
P1
P,
equals P2.
yep. And then the formula is z, is z. So it's pretty long. So it's like
I know.
the p's minus each other, p hat minus each other, minus the regular proportions 1 and 2 over the square root of p hat times 1 minus p hat times 1 over the 1 over the come on
Sample 1.
thank you, sample 1 plus 1 over the sample 2, and
2 is
number
the same
3.
same thing, right?
No, 3 is a little bit different because it's
Oh no, you're right. I'm sorry.
yeah, it's P1 and P2 hat, I mean, plus or minus the z scored to the square root of p hat minus times 1 minus p hat, and then over the sample 1 plus the same formula with just being p hat 2. So that being, so that's the formula to which we do. The next part is check the requirements, and that's going back with all those, whatever the sample times the 1 times the p hat, or the sample times 1 minus the p hat,
Yeah.
and those are your things to all equal is greater than 10. But it's, I mean, you probably figured this out, but the one thing is like, that would make sense. Is like the first one is 63 and the second one is 27 just because X. It's not, you don't have to do any of the P. So it's like, okay, because
Yeah.
I'm an idiot. I just realized that today. And then
But
the
they're
other
not the
one,
same numbers.
huh?
They're not the same numbers.
64.
Right?
Well, I came out to 64, but it's really 63 because if you do it, 64 over 296 times 296 is going to bring, so 0.215 times 296 is going to bring you to 60, 64, 63. So
Where are you getting that from?
number A, we're talking about A.
Yeah, but why would you when it's just X1 over N1?
Yeah. So,
If they
so that's like 63 over 296, right?
Yeah.
So you have to, it's two, the requirements are, it's the sample times the,
Yes. Okay.
so
Yes,
if you
I'm
can just
sorry.
take all that formula, you can take that formula out and it's just X is your form. So that helps you to
Okay.
solve one of the requirements. And then the other requirements is 1 minus the thing times that. So that's the where you actually have to do the calculations and stuff like that. So that just actually really made it easy, a lot easier. So so the requirements have been met, yes, because they're all larger than 10.
Yeah.
Okay. State the null and alternative hypothesis.
P1 equals P2 and P1 does not equal P2.
That is correct. Compute this test statistics. 3.309 And I really, really like that Excel that they gave us because you just put the things in and it came out.
Yes.
Compute the p-value, and again, by making sure that you put the right null alternative hypothesis, you get p equals 0.001.
Yes.
Yeah. By 0.001 is less than 0.05, so therefore we reject the null hypothesis.
Hooray.
And state in layman's terms. I just said we have sufficient evidence that the men and women have different labels. It's a little bit longer than that.
Wow.
And then construct a 95% confidence interval. So I just put it into that Excel formula, and the things come out to 0.045 and 0.166.
Yeah.
And interpret the confidence interval you constructed in number 5. We are 95% confident that the true difference in the proportion of men being labeled users and women being labeled users is between 0.045 and 0.166.
What I got.
Okay. I mean, again, a lot of this is just alternating words. Like, so in this case, instead of proportion, make sure you use proportions in when you do the layman's terms instead of just there's a difference.
Yeah.
Other than that, I think we're done. And then we can go on to the test. You ready?
Yeah.
Okay, I'm going to go ahead and stop the broadcast.
Okay.